Hi guys, welcome to special moment, right? As the introductory video stated, right? So the first, this video is just going to focus on some aspects of the specialist portfolio, right? That is going to focus on the first section, right? We might not finish completely, however, it's going to be focused on it, and you're just going to go step by step just to help in guiding everyone that needs to do their specialist portfolio, right? And also people that just want to learn about science, right? And so the first one is about tissue preparation, right? And the subsection on that is about fixation, right? So this specialist portfolio is specifically for cellular pathology, specifically for histology, right? So the first subsection of the first section, right, is fixation, right? So there are different questions that is or different knowledge requirements that is expected IBMS to have, right? And sorry, different knowledge that IBMS is meant to know. You understand? So the first one, it's first question, because people are going to. One thing is this knowledge base, this knowledge requirement, it's kind of a guide on the kind of questions they are going to be asked, right? So the question, your training officer might set the question in different ways, right? However, just as a guide, one question that can come up is, so the question will mainly focus on your understanding about, right, the changes that cells undergo when they've been removed from the body, right? Because our body, right, histology is mainly about the study of human tissue, right? So when they remove from the body, what happens to them, right? Because they can't stay outside the body for a long time without the protein and everything breaking down, right? So they're going to break down, and the bonds are going to break, and then yes, they're going to decay. So they need to be preserved, right? So once they come out of the tissue, what changes do they undergo? Okay, so basically, once the cells come out of your body, right, they undergo atrophy, right, autolysis and petrification, right? And so this degrades the tissue, its components, right? It destroys the biological material and the morphological structure of the cell, which you can see under the microscope, right? And also there's reduction in antigenicity, right, which means that the antigens, right, are not read, as in they are not able to bind to antibodies effectively when they are undergoing any immunological test, right, or any of the biochemical tests that you undergo after the normal routine H&E, right? So I mentioned atrophy, right? So I mentioned atrophy earlier, right? It just simply means the tissue is wasting away, reducing in size, and getting weaker. And the tissue gets weaker, right, and wastes away by the so the tissue wasting away, right, it just simply means that the protein, right, break themselves down, right, and are being catalyzed by lysosomal enzymes such as protease and sulfatase, right? So, and I also mentioned lysis. So it's the process whereby tissues and cells degrade themselves through the process called phagocytosis, right? And tissues are digested using intracellular enzymes, and these are released from the rupture of organelle membranes, right? While putrefaction, right, it's more about the deposit of bacteria through microorganisms, filtration and all that, also like bacteria building up, right? If there's tissue are not dealt with properly. In order for the tissue to be in a lifelike state, right, just like it is in the body, maintain the same temperature and not break down and not undergo any of the atrophy or autolysis or the putrefaction, right? In order for this to happen, they need to be fixed, right? And there's so many fixatives that are being used, right? But there's one in particular that is used, right, routinely used, right, which is called formalin, right? And also it can also be frozen, right? The tissue can be frozen, right? But there's also like a technique, there's a level at which, and there's a time frame at which these things can be stored, right? However, for it to be maintained itself, it needs to be fixed. All right. So aside from preserving the tissue, right, fixation, what it does is that it also maintains its morphology, the structure, right? And you can see this under the microscope, right? And it also prevents, right, prevents of opportunistic bacteria from getting into the tissue. It also prevents intrinsic enzymes, right? And also like lysosomal enzymes, right? So it increases the mechanical strength for the tissue to preserve the morphology of the tissue, because it enables micromolecules to be resistant to water and other liquid. They can also ask, because they want us to know the classes of fixative that we can use, or that they are known, right? So there are 3, right? Coagulant fixative, dehydrant coagulant fixative, and non-coagulant cross-linking fixative. So coagulant fixative are either organic or non-organic solutions. When coagulant fixative are used, right, proteins are insoluble, right, and the types of protein that are coagulated are lipoproteins and fibrous proteins such as collagen. Coagulant fixative causes flocculation of cytoplasm, poor preservation of mitochondria, and circuitry granules. Coagulant fixative are not beneficial for ultracellular aspect of the cell, right? So these are not used for electron microscopy. And dehydrant coagulant fixatives are fixatives such as acetone, methanol, and ethanol. So when using methanol, it enables more of the hydrophobic part of the cell to be fixed, because it's closer to the structure of methanol is closer to water than ethanol, which means it's more hydrophilic. So this dehydrant coagulant fixative, right, helps remove free water from tissue and cell, so they dehydrates the tissue. So they work by water molecules surrounding the hydrophobic area of the protein, and through a method called repulsion. So through water repulsion, and then get hydrophobic areas of the tissue in contact with each other to form hydrophobic bonds. So once the water is removed, they destabilize the hydrophobic bonding. Water molecules are bound to hydrophilic areas, and when water is removed, it destabilizes the bonds. Now the third one, non-coagulant cross-linking fixative. Right, this forms cross-linking bonds between proteins and nucleotides. So this third one, the non-coagulant cross-linking fixative, forms a cross-link between protein and nucleic acid. as well as other cells and tissue components. So another question can come about like what can affect fixation? This what factors that can affect fixation? So it can be pH, it can be a temperature, concentration, it can be duration of fixation, volume of fixative, penetration rate of the fixative or additive. There's any chemicals added to the fixative, it can also like affect the fixation, as well as osmolality of fixative and ionic composition. So there are different questions. There are more questions that can be asked because it's like there's more that we need to know for this particular section, right? So for now, we're going to stop, right? And we're going to continue another time, right? For now, right? Thank you very much for watching, right? And please, 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 don't forget to subscribe. Don't forget to like. Don't forget to comment. Add to it, you know, the things I've said. Add to what I've said. Let's help other people to be able to know about science, to be able to be better at writing their specialist portfolio, because everyone needs this, right? If you want to progress, most hospitals, right, if they can't give you a higher position if you don't have specialist portfolio. However, there are some will kind of be able to supplement it with like a master's degree and maybe other degrees as well, right? So it's important for everyone to have it. So I will encourage everyone, if you can do it, and if you have the if you want to do it, yeah, please do it and ensure that you do it. And if you have the resources and the help, right, in terms of finishing it. And one thing you should know that is that this specialist portfolio is mainly independent study, right? So they can only like give you the facility or the one or two trainers or something that will help you, right? But they're not going to like spoon feed you. You're going to spend your time to do your studies, right? If you do your work at home, try to get your practical aspects done, right? Sign whatever you do in the lab, right? Once you finish doing it, just ensure that yes, you get evidence for them, and then you ensure that yes, they get signed. So it's something that you are doing yourself, right? So once you're doing it, just ensure that somebody is there to help you sign. And if not, you will end up delaying it, because something you can do at a very short time. Well, within a year you should be able to do it, or even 1 year, 1.5 years, you should be able to do it, right? And if at all, you can spend 3 years to do it. But one thing is that just try to do it, right? And if you have the resources. And one thing is that when you're going to a lab and you want to work, it's important for us to, you know what, let me leave this advice from that time. However, please don't forget to subscribe, like, comment and share. Bye. Thank you so much for watching Special Biomed. Love you guys. Bye. Bye.